Good day. When you hit these problems with identities, you first must have a look about what side you wish to deal with first. In this case, the left-hand side seems to be a little bit more complicated than the right-hand side, and I always suggest people to try the more complicated side first. Note we have no square terms here, so the fundamental identities with the squares are not going to be used. So let's change everything into sine and cosine and see what happens there. Secant is 1 over sine, and you must put the theta there. Cotan is cosine theta over sine theta, and this is all being divided by 1 over cosine theta minus, now when you have a number, just place the number as 1 over 1, or if it's 3 over 1, put 3 over 1, etc. We now need to find the common denominator in the numerator first, which is already sine. So this can become 1 minus cosine theta over sine theta. On the bottom, though, the common denominator will be cosine. So there's already a 1 there, that cosine. So minus 1 over 1 is the same as minus cosine over cosine. So this becomes 1 over cosine theta. A fraction over a fraction, place the binomial in a bracket, and we multiply by the reciprocal of this denominator, which becomes cosine theta 1 minus cosine theta. This binomial will cancel off with that binomial, and then we're left with cosine theta over sine theta. If you recall earlier, cosine theta over sine theta is cotan theta, and that's what we were looking for to prove. So we go RHS, meaning right hand side. And now you're done.